Here we're looking at what we thought would be a non-symmetrical polar observation obtained with a 20,000 hertz neon sign transformer, integral plus, advertised as energy saving electronic gas tube sign power supply. And then we got two bulbs in series going across that, and the endpoints then are those silver aluminum bars. So when we're looking at the amount of polar discharges and whether they're symmetrical within both ends, we had some problems inadvertently. We were running the transformer ungrounded, and apparently in the ungrounded state maybe, there's no symmetry involved with how much gas discharge we can obtain from each side then. So without further ado, we'll separate each side. Since we don't know if it's ungrounded, we have to be a little careful or not. Well, I don't feel safe enough with that. So we can see then from that side we're getting discharge. And then we're going to repeat it from the other side. First we'll reestablish full contact. Now it quit working again. Totally. I don't understand. I'm going to manipulate these things. The tube's getting too near the power point or something. Amazingly, these have to foul up like that. Oh, our other end become disconnected. So that's without any end. Which goes to show, you see, there's the question there. We have to show this again then. When we disconnect the active end, nothing happens. And we reconnect that active end, and we disconnect from the other end, which we assume to be the grounded end.
That's making noise.
And then in that instance we do procure a polar discharge. So that shows a non-symmetry involved. If this is the correct way the transformer is working, there's still a question of whether it's properly grounded. And then we want to make one final demonstration then. We'll shut everything off. We're going to connect two. These things cannot be near the supply wires at 20,000 hertz. Two oppositely phased induction coils, 4-layer bifilar coils, each of which has an open end. These open ends can be a pain in the ass. If you inadvertently touch them, you get shocked and everything else. So then we've got a short there. The short is the white wire. We'll turn that, reestablish our connections. Again, we got length problems. That should be okay. No, it's not okay. Something went wrong again. There is the wire there. Everything should be right. Wow, that's giving us a problem we don't understand right yet. We're still working on it. Okay, there we are now. Now we have the same thing as before, only we have a white wire in between the series bulbs, krypton to the left, no, xenon to the left, krypton to the right. We're going to break that circuit with that white wire. Then now we get a discharge that's a little different than from before. A more beaded like discharge on the krypton bulb. And we really haven't focused in on these bulb operations too well. But the point of the matter is now then, on this circuit, it's been interrupted at the midpoint spot magnetically. And this is a 20,000 hertz, and together them coils resonate naturally in space when they're together at 135,000 hertz. Individually about 250,000 hertz. We're going to separate them coils, note the correlating decreased amount of discharge. At different separation levels, we could find some active points. There's interference, and there's an agreement maybe. And there's a lot of ozone being presented here, but that's just to show the magnetic separation of that high frequency circuit. Thank you.